A player can place a $7 bet on number 3 and have a 1 by 38 winning probability. If the ball lands on 3, the player gets to keep the $7 and is awarded an additional 245. Otherwise, the player is awarded nothing and the casino keeps the $7. What's the expected value of the game? So remember, the formula for expected value is the winning amount times probability of win minus loss amount times probability of loss. So in this particular case, the winning amount is this $245. Now remember, although you get the $7 back if you win, but that's not something that you won. That's something that was your own money. So when you walked in the casino, you had that $7. So it's kind of a break even getting this one back. So the one which you really win is this $245. So 245 and the probability of winning is 1 by 38. And then in the event that you lose, then you lose your $7. So minus 7 is the losing amount. And if you win 1 by 38 times, one times out of 38, it means you will lose 37 times out of 38. So 37 by 38. So let's do it on the calculator. 245. So it'll be 245 minus 7 times 37 by 38. Minus 7 times 37. That will be the numerator. Negative 14 and divided by 38. So negative 0.368. So probably will be rounding to the nearest cent. So it'll be negative 0.37. So negative 0.37. So the next part was, if you played the game 1,000 times, how much would you expect to lose? So this expected value is telling you that each time you play the game, or let's say if you play this game many, many times, then on average, you will lose 37 cents per game. So that means that if you play it 1,000 times, you multiply this by 1,000. So that will give you 370. So you don't have to put the negative now because they say, what are you going to lose? So that lose already contains the negative in it. So in this part, you don't have to put the negative. So 0.37 times 1,000 is 370. So which means that if you play this game 1,000 times, you will overall lose $370. Consumer organization inspecting new cars found that many had appearance defects, while none had more than 3 defects. 5% had had 3, 14% had 2, and 24% had 1 defect. So calculate the expected number of defects. So now expected value, as we said, is probably a little easily calculated if you do it just by hand. But the second part of the problem will ask you for standard deviation or variance. And there StatCrunch is really helpful. So let's open StatCrunch. Let's see if I have another window here which can help me get StatCrunch. Yeah, okay, let's open it through this. Then I don't need this data. You know, you can also do it through statcrunch.com. And just open it brand new. And then I select everything, and if I backspace, everything is gone. So right now what I had was we had that 5% of the cars had 3 defects, 14% had 2. So 5% had 3 defects and 14% have 2. So here you will have the defects. Remember, probability is always the second column. So 3 defects is 5%, so 0.05. And 14% had 2, so 2 will be 0.14. 24% had 1. So 24% had 1 defect, so 1 defect would be 0.24. And now you have to be very careful about something. We did not have to worry about this issue in the previous problems because we were given probabilities of all possible scenarios. Here, it seems that probabilities are given for all possible scenarios because you are told that you can't have more than 3 defects. So we have the 1, 2, and 3 defects. But remember that all the probabilities have to add to 1, and these 3 probabilities are not adding up to 1. And the reason for that is that we don't have one situation here which is having no defects, which is 0 defects. So we also have to have this probability. If you miss this one, you will still get the correct answer for the expected value, but you will get a wrong answer for the standard deviation or variance. So just make a habit of putting that case as well, so as to make all probabilities add up to 1. So now, right now, these add to 19 and 24 is 43. So these add to 0.43. So subtract from 1, so you get 0.57 for the 0. And now we're ready. You know it's stats, calculator, and custom for the probability situations. So the expected value is 0.67. The standard deviation is 0.90.